Hello, we are Team CEE09, and we are working on the scour repair of Bridge 02106 in the town of Hamden, Connecticut, along with Mr. Mark Austin. Our group is working on a masonry arch at the east end of the culvert running under Dixwell Avenue and a public pedestrian trail. The arch has been experiencing scour for some time, and the Connecticut Department of Transportation has concluded that it is significant and in need of repair. Scour is the erosion of sediment at the foundation of a structure due to the strong flow of water, and we have been tasked to create a full repair and rehabilitation plan to mitigate the current scour and prevent it from happening in the future. The site is currently in no condition for the beginning of construction. There's many downed trees and overgrowth of shrubbery throughout the site due to lack of cleaning in the past few years. To get the site ready to repair the scour, a great deal of maintenance and debris removal must be performed. Our project also falls within the limits of the town of Hamden's wetlands. Because of this, when clearing the debris around the site and during construction, we must ensure that minimal damage is done to the trees and native species in the surrounding area.
Now we move to our analysis of design alternatives. Firstly, for the first portion of the project, we would be using bucket removal to remove water. We would first cofferdam the area using turbidity curtains. These curtains are made of a geotextile fabric that using floats and weights will support and prevent water from entering the area we need to work into. So we would annex that area using these turbidity curtains. Next, we would move to the bucket removal, and by using different bucketing techniques and different smaller water pumps, we would remove the water from the annexed area that has been created by the turbidity curtains. Turbidity curtains is a great idea, although it's a little bit more costly than what we had proven to be our final design, whereas bucket removal is also very laborious and would therefore cost even more money. Next, we move to the way we would control our erosion and sedimentation. We have in this alternative hay bale options. Using the hay bales, it would prevent water and soil from flowing down into the area that we're working on. So this would annex the wetlands area that we would need to work on. And then lastly, for our concrete design, so the main portion of this project is to prevent scour moving forward and to create a new foundation for the arch bridge. And so using a normal weight concrete was determined as an alternative. Using this normal weight concrete, we would have basically the same effects of what is currently happening, in that the scour would continue to grow and grow, and the foundation would just become unstable for a longer period of time. And those are our design alternatives.
Finally, we move into the final design phase of our project. First things first, the concrete design for this project has been decided to be an ultra-high performance concrete. This design alternative was chosen because there's a high compressive strength and a higher percentage of fine aggregate. This means that this concrete mix is denser and will be better suited to support the arch for a longer period of time in the future, to hopefully prevent this project having to be done for a very long time. There's also the addition of an air entrainment additive. This will be used to decrease the frequency of air pockets, and typically in design projects like this, you will see a 5 to 7% additive number. Next, we move on to the temporary bypass pipe. This pipe will be added into our culvert as a way to move water through the culvert, given that the area is prone to flooding during storms. This will help further protect the cofferdamming, which is the next section of our design. The cofferdamming will be, this project will be sandbagging. So around each side of the culvert, there will be sandbagging set up to help protect the area that will need to be repaired with the concrete. Every day we will have to make sure that there are pumps placed into the existing cofferdam area to remove any of the water that piles up overnight. Moving on to the final design phase is the erosion sedimentation controls. As previously stated, this project takes place within a wetlands area. That means that the banks need to be protected at all times, and that minimal designer effect needs to be on the area. This means protecting local trees, protecting the soil, and protecting native plants. Therefore, we'll be using a silt fence along the banks along either side, running down the river and the stream bed, to ensure that no erosion from the bed moves its way into the water, therefore protecting the project.